All right, so the fundamental theorem, I think this is the, by far the most important thing you need to make sure you know. It's all over the AP exam. And it comes down to, I think, this big idea right here. When f prime is positive, f of x is increasing, and the amount f of x increases is equal to the area under the f prime graph. That is what the fundamental theorem is saying. It's saying this area from A to B underneath this f prime graph is equal to the change in f. How much did f change, right? And so if f prime is positive, there will be a positive change here, right? Because we're basically going to have a positive area underneath that. And the slope, would be positive, right? F of x would have a positive slope. And so it makes sense that f of x should be increasing on that interval, okay? And so we have to kind of think about this. So in this case, this is our f prime graph, but this could be v of t, this could be some sort of rate function. It's all the same thing, right? So when f prime is positive on these intervals, then f of x is increasing, but the amount it increases is whatever this area is. So we know that f of x actually increased by 3 units from 0 to 3, and then from 3 to 5, we decreased by 1.5 units, right? And so some things you're going to get, like lots of different questions that are really the same thing. It says find f of 3 if f of 1 equals 10, right? And so you can make sure you can think about this. Well, f of 3, hopefully you can see it and see that f of 3 is going to be 13, okay? Because f prime was positive, the amount we increased was 3. If you weren't sure about that, you could set up the fundamental theorem. So the fundamental theorem just says the integral from 1 to 3 of f prime of x dx equals f of 3 minus f of 1. And so if we were going to evaluate that, this area underneath f prime, that equals 3. So let me see if I can put a little.
But isn't the area that equals 3 from 0 to 3?
Oh, good one. Yes, I messed that up completely. Yes, you're right. We should not. It should be actually from 1 to here. So this would actually be what?
Like a row 2.
It'd be 2, yes. So we're talking about from 1 there. So yes, thank you. So that would actually be 2, that area. And so we're talking about this would be 2 equals, I was thinking from 0 to 3, but it's actually from 1 to 3. Minus, and this would be 10. And so when you add that 10 over, you're going to get 12. So you actually get f of 3 equals 12, okay? Everybody good with that? And the same thing, if this was a velocity graph, it'd be the same question if it asked you, told you your position was 1 equal, at time equals 1, your position was 10, what's the position at 3? It's the same thing. Or if it told you the amount of water in a tank at time 3, if there are 10 gallons in the tank at time 1. These are all the same questions, all the fundamental theorem of basically seeing that, when the rate at which water is flowing into the tank is positive, that's the area is going to be the accumulation or the amount that f of x increases. And so realize if this was some sort of rate function like W of t or something with some sort of rate in gallons per hour, and these are hours, if you're going to do an integral, the integral, of W of t dt, this would be gallons per hour times hours. These would end up canceling out and would just equal the number of gallons, right? So this would end up being the number of gallons that had actually filled during that time period, right? So it's not how many gallons are in the tank, it's basically how many gallons actually flowed into the tank from time 1 to time 3. So 2 gallons flowed into the tank, so we have 12 gallons in the tank at time 3. Questions over that? If we were going to go backwards, realize f prime increased from 0 to 1, okay, by 1 unit, right? From 0 to 1. So if we know we're at 10 at time equals 1, how much would we have to have been at time equals 0? Yeah, that's right, 9. So we have this f of 0 had to equal 9, right? Because we had to increase by 1 unit from 0 to 1. Make sure, if you're not sure about that, you could then again, set up the fundamental theorem, 0 to 1, f prime of x dx equals f of 1 minus f of 0. And so this area equals 1, f of 1 equals 10, and then we're trying to figure out f of 0. Realize we add this over to the right-hand side, and if we solve this equation and we move this over, we get f of 0 is going to equal 10 minus 1. We subtract 1 from both sides and add f of 1. We're going to end up getting 9. Okay? And so the fundamental theorem will always work out. All right, if we're going to find the average value, if this is our velocity, let's say this is a velocity graph, what would be our average value of our velocity?
150.
So it would be this integral, yeah. So it's integral from 0 to 5, v of t dt. This would find our displacement. And so if we just multiply by 1/5, that divides by how much time it took. And so in this case, we went positive 3 minus 1.5. So we have 1.5 over 5. So this is how many like meters we went. This is how many in 5 seconds. So our displacement is like 1.5 meters in the positive direction. And we did this in 5 seconds. So on average, we moved at 0.3 meters per second. Everybody go with that. So everybody see how this integral computes the average velocity. It's calculating our change in position divided by the interval, which is the change in time, how much time it took. Okay, and so this is the average value of v of t. What if we were asked to find the average rate of change of v of t? So what would be the rate of change of velocity anyway? What is that going to be? Acceleration, right? So this would be the average rate of change of our acceleration. All right, so how do we find average rate of change? Not derivative. That's the instantaneous rate of change.
Divided by time.
Yeah, so it's going to be this v of 5 minus v of 0. So our change in velocity divided by, it's really just the slope. So it's going to be the slope from here. So our v of 5, we're looking at this, would be negative 1 minus v of 0, which is actually 0 on that graph, over 5 minus 0. So we'd end up getting negative 1/5. So our acceleration was negative 1/5, right? And you can kind of see that. That's basically just finding that slope from here to here. It's finding over this time interval, our velocity decreased by 1 unit over that 5 seconds. That's really what's happening. So our average acceleration was negative 1/5. Questions over that?